Thank you again for joining us today. We've had, as you can see, some really amazing sessions already. This is one that's very exciting for all of us affiliated with Yale Engineering, and should be exciting for everyone in the room, because we're about to hear from the innovators who are really making the cutting edge innovations that will change the world as we know it. So I'm Claudia Reuter. I head up the Roberts Innovation Fund, which is really our lab to market accelerator inside the School of Engineering and Applied Science that's really designed to help facilitate projects that are in the lab and help them get to market. And it's my great privilege to introduce Dean Jeff Brock, who makes all of this possible. And I also, if he's in the room, want to thank Will Roberts, who made the fund possible for the school. There you are. Hi. Thank you for joining us. So I will turn it over to Jeff.
All right. Well, far from being the person who makes this all happen, I think actually I owe a great debt of gratitude to Claudia Roberts, who's been the stalwart and faithful director of the Innovation Fund since her arrival a couple of years ago, and of course to Will Roberts for really making this all possible. It was a great moment for the School of Engineering to be able to facilitate and ramp up this opportunity to launch an accelerator fund within the school. This came about through some, pretty detailed and technical conversations with the provost's office about how we were going to do it, and we're grateful to Michael Crayer, who's here, Vice Provost for Research, as well as Scott Strobel, the Provost himself, for giving us kind of the green light to try something new and launch something within a school the way we have. But all along, this has been a really important and powerful collaboration between the School of Engineering and Applied Science and Yale Ventures, and how to work out the space in between, the interstices of these two organizations, has been a really exciting opportunity for us. It's coming through our third year of it. I think what we're really seeing is a great sort of proving ground for how culture can really eat structure for lunch, as they say. The culture has kind of taken off in terms of the way that the faculty are embracing these opportunities, the way they're rethinking how they think about their workflow, and not just launching straight into publishing all of their new ideas, but really taking a beat to say, okay, is any of this commercializable? Is any of this patentable? Is any of this something that we could work through with a team of support from the Innovation Fund group and from Yale Ventures to get something out into the world? That culture shift has really been the big breakthrough with this fund, and so I just want to emphasize that as we come into this, this Innovation Fund showcase, that what you're seeing is kind of like the third round of great enthusiasm from the faculty, and these are the folks that have kind of made it through that process and are really benefiting from that culture transformation. So I thought I was going to make these brief, but I've nattered on for a while here. So why don't I pass it off to our friends from Connecticut Innovation, Carol Malloy, who will introduce the next group. Thank you so much.
Thank you.
Hi, I'm Allison Malloy. Thanks for having me here today. This is my third year getting to introduce these awards, and I'm excited to be here, as I think that watching the innovation and the ideas spin out of Yale or grow here is a terrific thing. So a second on Connecticut Innovations. If folks don't know Connecticut Innovations, we are the venture capital arm for the state of Connecticut. We have about $500 million of assets under management. We're early stage investors for the most part, although we do later stage venture debt, and we are investing in funds these days. But we put out about 40 to 50 million each and every single year into startup companies that want to have a presence in Connecticut. And we support and invest in the majority of the great ideas that spin out of Yale. So it's terrific to be here today. So without further ado, let's jump through the presentations. Our first person speaking today, who's receiving an award or is Richard Habib with Parti.
Thank you. Hello, can you hear me? Okay. Okay. So, hi, everyone. My name is Richard Habib. I'm a computer science PhD candidate. And I'm going to talk about some work we've been doing on Parti. So, as robotics sort of enter more and more domains of our lives, it's kind of becoming clear that bugs can be really dangerous. And especially when you're thinking about something like a fleet of Teslas or factory robots, an exploit or vulnerability could cause widespread economic damage or physical harm. So how should these systems be designed in a software sense? So in an ideal world, the most safety critical software should be sort of simple to understand and reason about, and we'd be able to sort of like know what's on the device. But in the real world, in order to solve these sort of complex problems, we need really big software stacks, and that allows us to do the types of perception and AI computation that you need to like model the world around the robot. And because of the way that they're designed, that also leads to potential vulnerabilities, sort of the increasing complexity. And this is sort of where software exploits can crop up, and remote attackers can take hold. So where does Parti fit into this? So you can think of Parti as a sort of like a metaphorical brick wall, partitioning out the most critical safety and mission critical software on a device. And what's really key about Parti is it establishes really safe and protected communication channels between these different partitions, in order to allow you to sort of really clearly define like what are my security domains on a system. So this software that we've built is based on technology coming out of my group, and was used in the foundation of unicorn startup Vrkic, which is a blockchain startup. But the formal verification technology behind Certicos, which is the underlying operating system, is used to prove that there's no bugs or software vulnerabilities in the code, which is a huge boon to the safety and security story of our work. So this project is largely funded by DARPA through the vSpells program. We used it to build a drone, and even if this drone is hacked into, it sort of is able to avoid obstacles and complete as much of the mission as possible. And we sort of built it in hopes that it could inspire applications across many domains, like self-driving cars, medical devices, and this type of thing. When it comes to our sort of competition or other possible technologies in the space, where we really stand out is the ability to handle legacy software without sort of needing to overhaul your software stack in order to use what we have. And as you can imagine, the market is quite large for this. So, of course, trust is expensive, and the cybersecurity market for automotive is constantly growing. And because Parti is sort of a very fundamental operating system software, it could be used on many different types of devices. And right now, sort of anything that has an ARM chip is a potential target. And sort of we are looking to release sort of an alpha version of our code in the coming months, and currently working on finding investor partners and initial sort of first customers. And we've been doing ongoing research on the formal verification side of things. So like I mentioned, I'm a PhD candidate here, and my advisor, Zhang Xiao, co-founder of Vrkic, and a professor here at Yale. We also work with Man Ki-yoon from NCSU, and a number of other doctors and other people from our group do like related work on this project. So it's a really exciting team. And yeah, if you have questions and like want to talk, please email me or talk to me after this. So we would love to chat more. Yeah, thank you.
Thanks, Richard. Thanks, Richard. So our next presentation is going to be by Jin Chen Zhao, and it's Millivolt AI.
So, hi everyone. My name is Jing Chen, and I'm a PhD student in applied physics, and I'm very excited to introduce you to Millivolt AI today. So, as everyone here should know, AI has really taken off these years, and it has created sky-high valuations for multiple AI companies, especially for hardware giants like NVIDIA. But there is a growing concern of AI, which is that they are really energy expensive. So how we scale up AI models is we just put more and more compute in them, so they consume more and more energy. And in the foreseeable future, this trend will just keep growing. So there is a really risk that this kind of energy expensive budget of AI is going to prevent us from its promise and profitability in the future. And to cut to the chase, we propose a very simple idea that we simply lower the voltage of the electronic circuit that we run machine learning models on. For example, from volt to millivolt. The direct benefit of this is that you can reduce the energy consumption by up to 1 million times. But the downside is that suppose you operate a transistor at volt level, then the electrons will flow very stably across this transistor and it gives you a very reliable output. But suppose you operate it at the millivolt region, then there will be only very few electrons moving, and due to thermal noise, they will like stochastically move around. So it will give you a very unreliable output. So this is where our physics background comes in. Instead of the conventional modeling of transistors, which is modeling them as a binary abstract 0 and 1 values, we model those transistors as stochastic electronic neurons, so that if we incorporate this kind of physics mechanism into the training, then a very large cluster of transistors can still give you a very reliable neural network output. To give you a real-life example, suppose you want to build your team as a manager, then you cannot expect every member of your team to be very perfect. But instead, some of them may be good at generating ideas, but poor at executions. Some of them are fast, but error-prone, and some may get lost in too much details. And your job as a manager would be to use the strengths of each team member so that the total team is greater than the sum of its parts. So this is exactly what our algorithm is trying to do. We are training those transistors collectively and incorporate physical knowledge into our training algorithm so that the total circuit will behave very reliably as a large neural network. And if you look back 20 years ago and see the very first server that Google built, then it does not look very good. So they didn't buy any high-end chips to build this very first server. Instead, they bought a lot of very cheap and faulty motherboards, and they connect those motherboards together, and they apply error correction code on it. And this allowed them to build very cost-effective servers back then, and this enabled them to challenge the dominance of Intel back then. So we are doing something very similar here, but we are going one step further. That we are, in the sense that we are modeling the whole circuit from the physics ground up, so that our energy efficiency is only limited by fundamental physical principles. So we have done a lot of proof of concept simulations. This is one example where for our image classification task, we show that with a millivolt chip, you can reach the same performance with a volt level chip with only 0.01% of the energy consumption. And as a sacrifice, you will need to increase the chip size by 8 times, but that's a really small overhead compared to the energy gain you can potentially get. And with Robert's Innovation Fund, we are trying to take our first steps to realize this algorithm in real hardware and also design our new hardware. So with no doubt, this is a really big market, and our final goal will be to compete head-to-head with those big hardware companies. But as a starting point, we will focus on edge computing, such as those chips in robotics and sensing applications, and we are very open to conversations. So at last, this is our Mutable AI team, and feel free to reach out to Logan and me through email. And this is a link of our group website. You can also check it out. Yeah, thank you.
Thank you, Jinchen. Our next presenter is Ali Matok, and you're going to be going through Chronosense.
Hello, everyone. My name is Ali Matuk, and I'm a postdoc working in the computer science department with Professor Ying. And today we're going to be presenting to you our venture, which is named Chronosense, which aims at scaling intelligence in measurement-based domains using foundation models. So when we mention measurement-based domain, this includes finance, manufacturing, and others, and our solution works for those type of domains. But right now we're going to be focusing on telecommunication because we secured multiple customers' interest in our solution. And just like any of these domain, telecommunication issues are numerous. So the first problem is anomalies. So imagine you have a network with a lot of antennas working together to give you the connectivity. Things can go wrong, and you have an engineer that has to find out what's wrong, and that costs a lot of money for the operator. Basically, 25% of their revenue is spent on this kind of issues. And also, operators, when they do deployment for customers, they have to be always in the loop, and that costs a lot of money. So it would be great if we have an intelligence that helps us alleviate this kind of issues. And this is where our solution comes into play. Basically, it's beyond just ChatGPT and GPT wrappers because these are not enough to solve this kind of problems. But instead, integrate various input forms, especially time series. That's why we will focus on measurements, text, diagrams, and all this kind of multiple modalities. And it helps us reduce operational costs by working on applications such as anomaly resolution and root cause analysis. So how does this landscape look like right now? So right now, if you're an operator, you have two choices. Either you partner with big AI companies such as OpenAI, Perplexity, which can provide you foundation model solution. But first of all, they don't necessarily have that telecommunication expertise. And because of the high cost, typically it's focus on one task rather than holistic approach to the telecommunication issues. Or you go for telecom startups, which are typically focus on one specific issue as well and do not provide foundation model solution. And this is where Chronosense comes into play, where we provide foundation model solution, and we have the expertise needed to make this possible. As for the market opportunity, as according to a McKinsey report, the entire AI market in the telecommunication industry is around $450 to $600 billion. If we go to generative AI market, it's up to $100 billion. And given our focus on US market and basically the main customer pain point we've seen, we find the market to be around $6 to $15 billion. So to date, our progress, we have established a lab that allows us to emulate data that I'm going to talk about in a bit. We launched first the open source model. We already got good feedback on it. We have thousands of downloads on Hugging Face. We created solution using graphs to create domain-specific models to help cater the knowledge towards that domain. And we already secured the early interest from companies such as Nokia, AT&T, and Raytheon. So this is our lab that we've been working on, so where we can basically go to the customer hey, this is something that looks like your data, and we've created solutions for it. So it makes us more legitimate. And I'll let Rex take the relay here about the solution.
So our mode is not just limited to the hardware and the data sets, which are, of course, unique across the industry, but we also have a lot of research experiences and model architecture development for this kind of unique models that require understanding of the literature, understanding of the time series signals, as well as natural language reasoning capability. So on the left, we have designed multiple state-of-the-art hard architecture on time series multimodal foundation models. And on the right, we have a demonstration of our proof of concept where the model identifies multiple channels of signals from the telecom network providers, network testbed, and was able to reason with the question and identify anomaly and provide a solution to it. And in the future, we plan to expand this kind of use cases to other scenarios, including supply chain, finance, energy, and other industry. We have a lot of ongoing customer interest, as Ali mentioned, and here are some examples from Raytheon and Nokia. We also talking to AT&T, Ericsson, and many other big companies. Our team consists of myself, Rex, who's an assistant professor in computer science. I specialize in AI, foundation models, graphs, time series, any kind of structured data, machine learning. In the past, I have I've been a founding member for a previous startup. My co-founder is Leandros Tassilas, who's a full professor in Yale Department of Electrical Engineering, and he's an expert in telecom and was able to provide the hardware and the processing system that are necessary for telecom research. And we also have founding members, including Ali, who's currently a postdoc, but will be finishing soon, as well as a senior PhD student who will be graduating soon, Jialing from my lab. And finally, Xiao, who's an alumni at Stanford and CEO of a very successful company. Thanks.
Right. Yeah. Please feel free to reach out, and we'll be here also like for any discussion.
Thank you. Thank you, gentlemen. I'll grab that. Our next speaker is Arman Cohen, and Arman's going to be speaking about SciMentor. Thank you.
Good morning, everyone. So I'm going to talk about our project, SciMentor, AI-powered virtual research advisor. So one question a lot of us might have asked at some point is, why do scientific breakthroughs take so long? Is it the lack of talent or researchers or scientists? It turns out not quite, because there's lots of talent around. There's in the US alone, there's 1.8 million researchers. And around the world, we are looking about 9 million researchers. However, these researchers need expert guidance and mentorship to be able to execute on their ideas. So two major problems that researchers often fall into is they might be trapped in cycles of iterations, of trials and errors, and they don't know how to get out of that cycle. And if there's not the right mentorship there, they might not be able to make the critical decisions, and making decisions in isolation can slow down research. So expert mentors are critical. And in universities or industry research, they really provide guidance for more junior researchers. However, access to this technical expertise is extremely limited. In universities, for example, a lot of labs, there's only one advisor, and there are 10 students who are trying to take bandwidth from this advisor. So our solution is, can we use AI to help with this? Can we amplify expert mentorship to junior researchers? And we are imagining this as a kind of an interface that sits between the researcher and the advisor, and then they can basically get any feedback they want during all the research life cycle. And it provides expert-level guidance that allows researchers to perform high-level research and execute on their agendas. And it also aims at complete research life cycle, not just focused on some specific parts of the research. So this is one one example of a research life cycle that is common across a lot of STEM fields, that starts from ideation and literature reviews, and then there's experiment design and execution feedback and iteration through experiments, and finally dissemination and release. And our SciMentor product is aimed at providing feedback in all of these stages. And one important thing is it is going to be continually learning and adapting efficiently to domain knowledge that exists across the fields. And also we provide on-prem deployment for companies who want to just do in-house research. So we've had some accomplishments during the past year. And for example, we had an agent that can provide paper critiques that are on par with human experts. We've provided another agent that can help designing experiments. And currently we are looking into multimodal integration and generating figures that allow users to better understand the ideas behind projects. So you might ask, what are the competitors in this space? It's actually a very fast-moving field with AI and LLMs. There are like generalist LLMs developed by OpenAI and Anthropic, and there are like specialized systems that aim at scientific innovations. However, our solution is different in that it targets the full research life cycle. Others are focusing on point solutions for a specific applications, such as summarizing research, answering questions, or doing search over literature. And we estimate the total addressable market to span over 29,000 universities globally and also in industry research labs. And even conservatively, the serviceable market is around like 1,800 universities in Americas, which we're looking at about like 93 million addressable market. So this is our timeline, basically. We've already got significantly positive feedback from universities who have been testing our product. We are moving quickly, and and this is our team. Myself, I'm an assistant professor in computer science, and two of my PhD students who are also founding members of the team, and they're experts in language model development and AI agent. Thank you so much. Please feel free to reach out if you
Thank you, Arman. So our next presenter is David Van Dijk, and David's going to be presenting Neurovox.
Thank you. All right, thank you for having me. I'm David Van Dijk, co-founder of Neurovox. We are building an AI-powered wellness companion for older adults, a solution that brings peace of mind to families and supports independence for seniors. Our team comes from Yale and Columbia, blending deep technical and clinical expertise. We are facing an elder care crisis. By 2030, 1 in 5 Americans will be over 65. At the same time, At the same time, the caregiver workforce is shrinking down 10% in the last decade. Loneliness among seniors drives $150 billion in avoidable ER visits. Most of this care, 90%, is simply conversation. How are you feeling? Did you take your meds? But today, that's slow, reactive, and expensive. Neurovox transforms this challenge with daily, automated voice check-ins. Our AI calls each senior, checks mood, and confirms medication adherence, then delivers real-time alerts and updates through a dashboard for families and staff. There's no hardware to install, and it works on any phone. This lets us reach everyone without barriers. The timing couldn't be better. Advances in voice AI and natural language processing mean we can detect tone, mood, and cognitive changes with over 99% accuracy. There are 14 million US seniors living alone, a true loneliness epidemic. Since COVID, telehealth use has skyrocketed, and crucially, Medicare now reimburses for remote monitoring and mood screening. All the pieces are in place to make this work at scale. We're not just an idea, we have early traction. Over 100 users have tested Neurovox with 95% call completion rates and high satisfaction, 4 out of 5 among both seniors and caregivers. We are launching pilots in 3 care facilities, covering 500 residents. The data shows strong engagement and real-world demand. The market is huge, 29,000 care facilities and 1.3 million residents in our initial scope. Our business model is flexible, a B2B SaaS for facilities at around $5 to $13 per resident per month, and an optional $20 a month plan for families who want direct peace of mind. With this, we can serve both institutional buyers and individual families, expanding our total addressable market. Neurovox stands out from its competitors. We're the only truly proactive voice solution, hardware-free, with real-time emotion analytics and a unique dashboard for families. Other solutions either require new devices, are passive, or focus only on emergencies. Our approach is accessible, affordable, and drives deeper engagement. Our team brings both world-class technical and clinical expertise. I'm a professor in computer science and medicine here at Yale. Mandy is a clinical professor of psychiatry at Mount Sinai with deep expertise in geriatric mental health. Ivan is a researcher at Yale, specializing in AI and voice technology. Together, we combine research, clinical insight, and technical execution. Our vision is simple: empower independence for millions of older adults and deliver peace of mind for families. With Neurovox, we can reduce emergencies, lower care costs, and enable happier, more connected lives. We are ready to scale, and we're excited to make this impact real. Thank you.
Thanks, David. Our next presenter is Anne-Marie Rickman, and she will be presenting Carvis Health.
Hi everyone, my name is Anne and I'm here to present Carvis Health, a tool for personalized digital simulations of heart surgery. Heart valve disease is a significant problem. It affects 8.5 million patients in the US, and it's projected to a 3 times increase in volume by 2050 due to the aging population. It can cause downstream damage such as heart failure and even death in some cases. Despite the progress in treatment, the problem is it hinges on the doctor's level of experience, and failure can lead to complications such as death. When we look into the current clinical workflow, we notice it's slow and based on intuition. So when a patient has heart valve disease, the doctor will usually take a computer tomography, a CT scan, and look at the heart. These CT scans are 3D, but the problem is when the doctor do measurements, they can only do line drawings in 2D, and this is oversimplified, as you can see in this schematic. Then they take the CT scans and the measurements into a planning meeting where they discuss with other doctors, and they come to an operator-dependent conclusion based on guidelines and their own personal experience and intuition. Our solution, Carvis Health, will make this process more automatic and also less operator-dependent. So we start with a doctor who has a question on how to treat this patient with heart valve disease. They have already taken a CT scan in the hospital, and they can upload it to our Carvis Health cloud. We then run some simulations and can provide the doctor with PDF reports and videos that give them more information on how to treat this patient. Our software is comprised of 2 steps. The first one is an auto-meshing algorithm with AI, And the second one is a fast physics-based simulation pipeline, where we take the meshes that we have created in the previous step and then can run simulations, for example, seeing how a certain device like a valve or a stent can affect this specific patient's anatomy. We have published a bunch of papers, first in technical journals. Then we established key clinical collaborations with MIT, Stony Brook, and Cleveland Clinic, and finally published a paper in Nature Portfolio, which led to a US patent filing. And recently we were awarded with the Roberts Innovation Fund. When we look at how we can commercialize this, we noticed, compared to our two key competitors, DASI Simulations and FEOps, that we have some major advantages. For example, we're using AI for our meshing algorithms, and also we're building the fast physics-based simulation pipeline. Here are also some testimonies from two of our key clinical collaborators who mentioned that our approach is useful. Our key technology, the meshing and the simulations, can be used in different procedures, but we're focusing on TAVR, which stands for transcatheter aortic valve replacement. We do that because it's a high-growth market, and it's quickly becoming the clinical standard for a high volume of cardiology patients. We can later extend to other valve replacements, such as mitral valve or tricuspid valve, and even extend to other imaging technologies like ultrasound. Looking at the market, we believe we can get FDA 510K clearance relatively quickly, and assuming $1,000 per analysis, the total addressable market is around $1.2 billion US, and we believe that we can capture around 300 million of that. This is our roadmap, so we're currently still building our product and doing user interviews, and soon we will continue with a pre-submission form for FDA clearance and setting up our pilot customer. This is our team. We have Daniel Pack. He has a PhD in AI and machine learning for personalized heart simulations. And the research we have published so far is based on his PhD and postdoc research. He's a Yale Ventures Fellow and a T32 Fellow. I recently joined the team. I also have a PhD in AI and machine learning for medical image analysis and a background in AI for meshing. We work closely with Jim Duncan, who has 40 years of experience in cardiac image analysis and is the department head of Yale Biomedical Engineering, as well as Ted Kim, who has 20 years of experience in physics simulations, and he used to work at Pixar, where he won an Oscar for his work. Thanks.
Thanks, Anne. Thank you. Our next presenter is Peter Rakich, who will be presenting resonance microtechnologies.
Thank you.
Thank you.
Wonderful, thank you. Hi, my name is Peter Rakich. I'm a professor in applied physics, and I want to tell you about some exciting new oscillator technologies that we've developed in my group that we're eager to commercialize in a new venture called Resonance Microtechnologies. So first of all, what are oscillators and why do we care? Oscillators are used to define frequency and time and to measure those very precisely. They allow us to make very precise measurements as the basis for sensors, communication, and navigation. Oscillators are basically everywhere. Your iPhone, your Apple Pencil doesn't work without it. So for example, better oscillator performance translates to much improved performance for a number of technologies. For example, improved oscillator performance translates to more bandwidth for wireless data transmission, more sensitivity for a sensor, higher accuracy for GPS. So what's stopping us from creating better oscillators as a basis for next generation technologies? So the basic problem is conventional oscillators are noisy. So the conventional approach to making an oscillator is to trap sound waves inside of a crystal, making something kind of like a tuning fork. So the frequency of this resonance is what helps us define the frequency of the oscillator. The problem is that because we're trapping this excitation inside of a material, we suffer material noise. It turns out there is a way to get around this, and it's been used in laboratories all around the world. And that is to use light rather than sound to create an oscillator. So the idea is that we can confine light between two mirrors. And because light can propagate in vacuum, this allows us to create a resonator that stores its energy entirely in vacuum, eliminating the material noise that we would otherwise suffer in crystal oscillators of a conventional type. So what's the catch? So why are we not able to use this technology right now? In laboratories around the world, which this technology is used in labs to make the best oscillators on the planet. The problem is that these are really big and clunky systems. The optics that are used, we put this big optical assembly inside of a big vacuum system that you see on the left. And this vacuum is this optical system uses very expensive hand-polished super mirrors, and this handcrafted assembly is placed inside of the vacuum system. So this is clearly not a portable, scalable technology. We at Yale have found a solution to this. We've developed a new process for creating these otherwise handcrafted super mirrors with microfabrication. We've also developed a new process to combine these microfabricated mirrors and manufacture in a wafer scale approach arrays of such cavities. And we bond them together in vacuum, eliminating the need for this big vacuum system. So this gives us millimeter scale devices that have a similar performance to these massive laboratory scale systems. And this could be really revolutionary in terms of clock performance. So how did we get here? Over the last 6 years, this work is the result of 2 very successful DARPA programs. We developed this new micromirror fabrication technique and this strategy for creating and manufacturing these vacuum gap oscillators. We've also developed new chip scale integration techniques that allow us to combine these resonators with integrated photonic circuits, chip scale integrated photonic circuits and electronics to make world-class oscillators for microwave signal processing, as well as world-class laser performance as a basis for a variety of technologies. And due to a lot of interest that we've seen from industry, a lot of defense companies as well as private companies doing quantum computation, et cetera, have reached out to us because these sorts of technologies have broad impact. This has spurred us to develop this company, to start this company called Resonance Microtechnologies. Our objective here is to deliver component technologies such as these micromirrors and these microcavities, which have a very important role to play in defense and commercial sectors for example, precision measurement as well as for quantum computation. In addition, we want to use these new strategies to integrate these oscillators with photonic circuits to create modules. These modules are somewhat more sophisticated and will enable the creation of new sources for satellite communications, quantum sensing, and a variety of other applications. So last but not least, I want to acknowledge my team. At Yale University, who's really made this happen. Also the Yale Clean Room. So thank you very much for your support, Yale University. As well as, I want to acknowledge Greg Luther, the co-founder of this company. He's got 20 years of experience building up companies for the defense sector. So if you want to reach out, please reach out if you want to learn more. I'd be happy to discuss. Thanks very much.
Thanks, Peter. I think I botched your last name. My apologies. Our next presenter is Ryland Todd, and the presentation is Canary Sensor.
All right. Hi, everyone. My name is Rylan, and I'm excited to introduce the Canary Sensor for household water purification systems. I am a PhD student and researcher on this project, and I work alongside my wonderful team, Dr. Young-Hyun Kim and Professor Jae-Hong Kim. Our team is based in the Chemical and Environmental Engineering Department here at Yale, and much of our research focuses on water quality. Because of this, I know more than I'd ever wanted to know about the kinds of pollutants that find their way into our water supply. These include pesticides, pharmaceuticals, and carcinogens like PFAS and PCBs. These present a danger to public health and to the environment, and recent regulatory rollbacks are only increasing this danger. So how are individuals supposed to protect themselves? Well, many have turned to household water treatment systems. This is reflected by an increase in demand for these systems, with the market size expected to reach $75 billion in the next decade. But the question is, do these treatment systems actually work? Well, if you have the Brita filter or something similar in your home, you may be familiar with the current paradigm. You refill the jug until the green light turns to red, at which point you replace the filter. But the problem with this is that there's no way for you to know when the filter has reached capacity. You could be drinking water with this stuff in it. But what else are we supposed to do? Current technology offers no way to monitor overall water quality. You would need an absurd array of different instruments to measure all of the usual indicators. And even within these measurements, there's no measurement for organic pollutants. So our team decided to use our expertise in environmental chemistry and in catalysis to solve this problem. To find the answer, we decided to look to the past. When coal miners faced the threat of dangerous gases, they carried canaries with them into the mines. Because the canaries are more sensitive to these gases, the miners would know to evacuate when the canary, well, stopped singing. So we thought to ourselves, wouldn't it be great if we had a canary but for water? So the idea for the canary sensor was born. The idea is simple. When contaminants are below a certain threshold, the canary sensor does not respond. But when the water quality changes, the canary sensor sends out a warning. So, how do we do it? Our central hypothesis relies on the idea that a conductive material, the accumulation of organic contaminants on a conductive material changes its electrical resistivity. So our system relies on a conductive adsorbent whose resistivity is continuously monitored as the water passes through. When molecules like organic pollutants adsorb onto the material, its resistivity changes due to the altering of electron transport through the material. Therefore, by measuring the resistivity of the material, we can monitor the overall water quality and get an alert when the contaminant concentration is too high. Here you can see some proof of concept data showing the response of the material to the chemical BPA. What's important to note here is that these signals can be translated to report the pollutant concentration, proving the validity of the mechanism behind the canary sensor. I've been conducting these experiments in a tiny electrochemical cell like this. Water flows into the cell and through a small channel. It then flows through the three-dimensional conductive carbon material, where this is the most important and innovative part of our system because this is the material that enables the canary to sing when the water quality changes. In addition to developing this prototype, we have been in communication with some of our target clients, including the South Korean household appliance brand Kowei. Luckily for us, they are very excited about working with us and about potentially manufacturing the device to bring the canary sensor to market. We've also filed a provisional patent, and we are looking at relationships with other potential clients, such as Aquasana, Brita, and Pure. So in conclusion, our team has developed a produced proof of concept data, developed an initial prototype of the canary sensor. We've also filed a provisional patent, and we are working with potential clients like Kowei to facilitate the translation of the device from the sensor, from the lab to the market. But there is still much more exciting work to be done, including optimizing and calibrating the sensor and leveraging machine learning to interpret the sensor response to various analytes. Thank you so much for listening to my presentation, and thank you to Roberts Innovation Fund and to my team. Please reach out to me if you have any questions or ask me if you see me around at the conference. Thank you.
Thanks, Rylan. Our next presenter is Bin Yun with photochemical carbon removal from seawater.
Hi, My name is Ying, and I'm a PhD student from Professor Kwabi Lab. And today I'll talk about the photochemical carbon removal from seawater. I'd like you to think about one of the first experiments that you did in elementary school. You may recall mixing oil and water together and watch two layers separate. Today, I'll talk about the potential way to harness this very simple principle to address climate change. Broadly speaking, our project aims to harness the power of sunlight and use ocean's natural capacity to absorb CO2 from the atmosphere and the use of tools of organic chemistry to extract CO2 from the ocean, which eventually pulls carbon out of the air by working through the sea. And ocean is a very interesting system to think about in the context of carbon removal and climate change because it continuously equilibrates with atmospheric CO2. Also, ocean has about 100 times more carbon per unit volume compared to the air. So if you think about it, ocean can be a very useful platform to extract CO2 from the air. But the challenge to this is that in a natural ocean, the carbons are present at bicarbonate, which is around pH 8. So one has to shift the pH down to pH around 5 to extract CO2, to convert it to CO2 and then extract it. And there are varieties of electrochemical and photochemical ways to do this, but they are fairly energy intensive. And as you can see from the right figure, they are often involve quite complicated several unit operations. And in general, the more unit operations there are, the more costly it is to run it at scale. So our project develops an entirely new approach to counter this problem of carbon removal from the ocean. We have a photoacid, which is a molecule that releases protons when it is excited by light or sunlight. And we dissolve them in a hydrophobic medium. So basically, when we have an oil that when we shine a light to it, the protons release to the seawater phase or the water phase. And the released protons will react with the bicarbonate or carbonate and release CO2. And once you're done with the carbon removal cycle, you put the photoacid in the dark, and they will regenerate for the next cycle of carbon removal. Thanks to this simple setup, we have several distinct advantages to other photochemical and electrochemical carbon removal from ocean water. So we are using two immiscible liquids, so we don't need a membrane, which can be costly. And we have a very simple hardware, and we don't need precious metals to this, and because we have a photoacid, and there will be a rapid pH change as you shine a light to it. And because we are harnessing the sunlight, there will be a low energetic cost as well. With the support from Roberts Fund, our goal is to demonstrate the feasibility of this carbon removal system at a lab scale by designing the photochemical reactor that does this and developing a performance modeling to test the system's efficiency and ultimately have an IP protection and licensing of our technology. And this is our team. Our team is supervised by Professor Kwabi, who has led various carbon capture projects and also has a carbon capture startup. And we have a collaborator from Texas A&M University who is an expert at making this type of photoacids. And Byron, who is an expert on developing this performance modeling, and myself working on the photochemical reactor design. And Abba, an undergraduate student who will assist us through this process. And thank you for your attention, and we look forward to share our results and progress in the future.
We have just one last presentation, so if everybody's able to just hold for 1 minute, that would be great. Our last presentation is Jin Ding with Soilify.
Thank you.
Hello, everyone. My name is Zhen Ding. I'm a PhD student in computer science at Yale, working with Professor Leandros Tassilos. Today, I will present our project SoilFi, a low-cost soil sensing technology to enable smarter soil insights with Wi-Fi and AI. Nowadays, farmers are facing big challenges of inefficient resource use and significant land degradation. To address them, there's a growing trend of adopting data-driven agriculture, which can help farmers make better decisions by insights from soil data. With the insights, farmers can improve yield, reduce resource waste, and improve the sustainability of their farms. However, data-driven agriculture cannot be easily afforded by farmers. Farmers are currently spending heavily on inputs like water and nutrients without accurate soil data. Most of them are doing annual soil testing by sending their samples to soil labs, which is slow and expensive. The in-situ soil sensors used by data-driven agriculture has high cost of upfront investment and data subscription, making them inaccessible to small farms. At SoilFi, we aim to bring down the cost to hundreds of dollars, which can help unlock over 20% of savings for farmers. We look at 3 key soil properties. Soil moisture is important for water resource management. Soil electrical conductivity is highly correlated with crop yield. Soil carbon is important for soil health and climate change. SoilFi can enable cost-effective, real-time, and accurate soil monitoring with smartphone and machine learning. Unlike the traditional sensor that rely on dedicated hardware and data logger, we use commercially available hardware without modification. We use a method combining traditional modeling and machine learning to achieve high accuracy. Also, there's no need for soil sample preparation. With machine learning-powered insights, we aim to provide farmers real-time recommendations on their phones. This line of work initiated during my internship at the farm-based team at Microsoft. It was exciting that I got to demo to Bill Gates. We have long-term collaboration afterwards, leading to multiple papers, a patent, and several awards. Earlier this year, we got the Roberts Innovation Fund, completed the NSF I-Corps program, and we are currently drafting patent application. Most recently, we also got the acceleration grant from Yale Planetary Solutions. SoilFi has several unique advantages. First, its price is much lower because we are using the widely available hardware. Second, it can sense multiple soil properties without any dedicated hardware. Finally, our device naturally has the wireless connection without extra cost. There are huge commercial and residential markets for soil monitoring. The total market size is $7 billion in 2024 and will grow to $13 billion in 2030. We have identified 2 potential partners, Microsoft and GrowGrew. Both companies are building data-driven agricultural platforms that rely heavily on soil sensors. SoilFi can help them significantly bring down the cost of soil sensing. In our team, Leandros and I will lead the technology development. I've been working on this topic towards my dissertation. Leandros has over 30 years of expertise in wireless technologies. Farouk, the co-founder of GrowGrew, is our potential consultant. Ranveer, the leader of the farm-based team at Microsoft, is our potential board member. We have been collaborating with him for a long time and will continue the collaboration. Currently, we are focusing on developing a basic live demo, then we'll use it for extensive field data collection. Then we will use the data to improve our machine learning model design to adapt for different soil types. We plan to launch our pilot program next year. Thanks for listening, and feel free to contact us if you have any questions.
Thank you all. Congratulations to everyone. And let's just do a final round of applause for everyone who helped present.